Hello everyone. Today I'm going to explain time delay in C program. So there are two ways to create a time delay in 8051C. So in the previous class we discussed about without time delay we perform some operation like toggleness and we displayed some characters by using a 8051C by taking some 8051C data types. But now we need some delay in between two operations. So for that, the creation of delay for any of the operation, there are two ways to create a time delay in 8051. One is using a simple loop creation and other one is using 8051 timers. So 8051 timers we are going to discuss in the next module. Now by using a small loop how to create a delay we are going to learn in this class. When we write a time delay we must use the oscilloscope to measure the duration of our time delay. The next we use for the loop to create a time delay. So in the time delay using a loop, we must be mindful of three factors that can affect the accuracy of the delay. What are the three factors? The first factor is the 8051 design. Since the original 8051 was designed in 1980, both the fields of IC technology and microprocessor architecture design have seen great advancements. The number of machine cycle and the number of clock period per machine cycle vary among different versions of 8051 bar 8052 microcontroller. So while the original 8051 bar 8052 design used 12 clock period per machine cycle. So by taking the 12 clock period only, the crystal frequency divided by 12 will give the time period of one machine cycle. So this is the design we adopted in a 8051 microcontroller. Many of the newer generation of 8051 uses few clocks per machine cycle, but we are taken 12 clocks per machine cycle. But now advanced microcontrollers will take very less clock pulse. So here we can see 4 clock period per machine cycle if you use this microcontroller DS5000. Okay, so similar way, this one also DS89C420 uses only one clock per machine cycle. So based on this, we need to calculate what is the time consumption or time delay we are going to specify. The crystal frequency connected to X1 to X2 input pin. The duration of the clock period of the machine cycle is a function of crystal frequency. So in general, 8051 microcontroller having 11.0592 megahertz crystal frequency. Other microcontrollers has 12 megahertz. Some microcontrollers has 16 megahertz. Some microcontrollers has 20 megahertz. Based on that, the formula to find is crystal frequency divided by number of clocks. So that will give you a time period. So compiler choose the third factor that affects the time delay. So based on that, the time delay we need to calculate. That is the thing. So based on that, you can see the toggle a bit of P1 continuously forever with some delay. So on and off it has to do. Okay. So for that, see here, first value we taken is P1 is equal to 55H. The second factor taken is P1 is equal to 0xAA, that is AAH. So these two are the toggle value. Before in the previous class we taken these two factors without a delay. So the toggleness is going to happen, but we are not able to identify whether it is going to doing or not. So based on that, we need to give some delay. So this is a delay size is unknown. So just one assumption value we taken, that is 40,000. Okay, 40,000. So here what will happen? X is equal to 0, x less than 40,000, x plus plus. So first it will display, okay. After that, once it becomes 0, up to that it is going to increment. Up to 40,000 time it is going to increment the cycle. Then once it will become 0, then it will display this AAH. Again it will take some duration, okay, the same duration 40,000. So up to that it will wait. Then after that again it will come back to the P1 is equal to 55H. Why? Because we taken the loop as repeated forever. If it is not repeated for forever, then once it will display 55, next it will display AA, then it will vanish. So here because of forever, it is continuously it is showing 55 and 44, 55 and AAH with some delay. So again, here the specified amount of delay is mentioned, and the crystal frequency also, as I told, we taken as 11.059 megahertz. So based on that, again we taken here, while we are taken here, that is also repeated forever. So P1 55H and again the P1 AAH. The delay we taken is 250 because it is given as 250 millisecond. So MS delay, millisecond delay 250, millisecond delay 250. So after 250 millisecond it will display AA. So you can see with the millisecond some delay is going to happen in between the display of 55 and AAH. So that is the thing is going to happen. Again, MS delay, that delay what we taken is 250, that we have a loop here. So based on this loop, this is going to perform, this instruction is going to perform. So like this, we need to create a delay. Again the same thing, 250 millisecond is given. The bits of P0 and P2, P0 and P2, toggleness we need to give. So toggleness means you know that one has to display one number, the other number, same the complemented value it has to display. So here two ports are taken. Initially these two values are going to display. After some delay, again these two values are displaying. After some delay, again it will come back to here. Okay. So delay, again we have a standard procedure to create this loop, and based on this loop the delay is going to happen. So like this, the delay has to be taken for any of the program. So here also same thing, uh, program to get a byte of data P1, wait for half second and send it to P2. First, P1 has to receive some data. The same data has to be sent to P2 with delay of half second. So first we need to send the data to the port 1. So port 1 value to the accumulator A, then accumulator A to the to the port 2. So like that we need to do the program. So P1, which data we taken? FF. Then my byte to P1. So my byte here taken. Okay. So this my byte consisting of this value. Okay. So this value will send it to P1. So after that we need to create a delay of half second. So half second delay is 500 millisecond is the time. Half second is nothing but 500 milliseconds. Okay. So this data again P2 will be displaying whatever the data which is available at P1. So same data, my data is going to display in P2. So everything is happening. Then this loop is purely for the delay creations. Okay, like that we need to do that. So here also same thing. Okay, same programs. So in the next class, we will discuss about timers, using timers or using timers, how the delay has to be you need to create. and some logical operation using C. So these are the content we can discuss in the next class. Thank you.